Dear students, how are you all? Well, today we will discuss chapter 3, that is force. You have some idea about force because we use this term usually in our daily life. So, but in term of physics is quite different, little bit different, not quite. So you will understand the force by discussing or understanding this chapter. Okay. First, inertia. Inertia and concept of force. That goes to Newton's first law. Okay. In the previous chapter, that is motion, we have learned about velocity, speed, acceleration, and deceleration. And their mutual relationship. We have decided the equation of motion and applied them to solve problem related to motion as well. In the chapter, we will learn how motion can be created or motion can be influenced by applying of force. Okay, the first part of Newton's first law that we will know. Newton's first law, a stationary object will remain stationary and an object in uniform motion will continue its uniform motion unless a force is applied to it. And we know velocity is a vector quantity, so force is also a vector quantity. Well, this is the first law of Newton. The first part of Newton's first law is not difficult to understand because we always observe that the body at rest remain at rest and do not move until pushed. The problem arises from second part because we never observe that a body is in motion, keep its particular motion forever. If motion is produced in a body by pushing it, we observe that the body comes to rest if no force is applied. From our daily life experience, it seems that to keep a body in uniform motion, we have to apply force on it continuously. From Newton's first law, we learned that it is not true. If a body is in uniform velocity stops, then we have to realize that force has been applied by some means. Friction, air resistance, etc. actually stops a moving body by applying force in the opposite direction. If all the forces could be withdrawn, then we will find that a body in uniform motion kept in perpetual motion forever. Well, or uniform motion forever. Why we won't find uniform motion in our daily life? Because surface friction, air friction, and other variables acts on it in opposite direction. Okay. Now come to our next topic. 3.1.1, that is inertia. The character that a stationary body wants to the character that a stationary body wants to be stationary, or a body in motion wants to keep its motion unless a force is applied, is called inertia. When a car at rest suddenly starts moving, we move backwards. This is an example of inertia. The lower part of a body is attached to the car. When the car starts moving, the lower part of the body moves with the car, but upper part of the body is still stationary and tends to remain stationary. So the upper part of the body moves backwards. Since the inertia is due to the tendency of rest, this is called rest inertia. If a body try to remain rest, is called rest inertia. When people get down from moving bus train, we see that the fall down due to the inertia of motion. The whole body of the person in a moving train or bus is in motion when he or she his or her leg touch the ground. The lower part of it becomes rest. The upper part of the body keeps moving forward due to the inertia of motion. So person falls down. We have an experience of inertia. We can keep a card on a glass and then place a metal coin on the card and flip the card and displace. You can display the card from there. You will see the coin will fall into the glass. This is another example of inertia. If the term inertia was merely different than it should be, through which so much importance. Actually, from the viewpoint of physics, it is very important topic. Up till now, until now, we have not uttered the word mass, but to know the motion of an object, we have to know the mass. We do not treat a light cycle and a heavy truck coming with the same speed of the same scale. The remain reason is the difference in mass. But actually, what is meant by mass? Often we say mass is a measurement of amount of object. Mass is a measurement of amount of object inside the body. But a more scientific answer is mass is the measurement of inertia. Okay, so mass is itself a measurement of inertia. If a body has a higher inertia, then you have to understand that surely it has higher mass. It If inertia is less, we can surely say that it's a less inertia. You definitely observe it that the object with high mass cannot be displaced by higher amount of applied of an equal amount of force, but a body with less mass can displace easily. Or there otherwise we can say if the mass is less, the inertia is reduced eventually. Our next topic is momentum. Let truck and a bicycle hit a small car with the same velocity in the collision. The cycle or truck, which one will damage the small car more? Definitely truck, because the truck is much heavier than the cycle. Through the velocity of the cycle and the truck are the same, but the momentum of the truck is much more than the momentum of the cycle, since the truck has the greater mass. Simply, the momentum is defined as the product of the mass and the velocity. The product of mass and velocity is called momentum. So P is equal to mv, unit kg meter per second. Okay. If the mass of an object is m and the velocity is v, then momentum is p equal to mv and unit is kg meter per second. Here, mass is a scalar quantity, but the velocity is a vector quantity. Therefore, the momentum is a vector quantity. We may think that generally the mass of an object does not change. So the change in momentum may occur only due to the change of its velocity. But in special case we may find that the velocity of the object has not changed, but due to the change of mass, change of momentum, what's happened? You may think instead of defining a new term, momentum, what was the problem to always treat if it as a production of mass and velocity. In general, it does not create a big problem, but in case of a particle of light, it may create serious problem. A particle of light or a photon has no mass, but it has momentum. Compared to the mass and velocity momentum, it is more fundamental quantity. Then they have a combination of momentum. If more of one object is in motion and the moving is different velocities. Due to the different velocities of the object, there are many collide with one another in their path of motion, and due to the collision of their velocities may change. If not, no force is applied from outside, the collision of the combined motion momentum will not change. This process is defined as the law of conservation of momentum. Law of conservation of momentum means the momentum remains conserved for all cases before collision and after collision. Okay. Now I have an example for you. See here. If you throw a tennis ball on a wall with a velocity of 10 meter per second, it will bounce back towards you with the same speed. If the time mass of the ball is 10 gram, what is the change of momentum? What is the change of momentum? Because there's a question. So answer. First momentum P equal to mv. After striking momentum becomes p prime equal to minus mv. This is opposite direction. Therefore, change of momentum del p is equal to p minus p prime. That means mv minus mv. That means 2mv. So here m mass 100 gram, that means 0.1 kg, and velocity means v 010 meter per second. That means del p is equal to 2mv is equal to into 0.1 into 10. So 10 1 2 2 kg meter per second. Okay, that's the answer of this question. Okay, for the change of momentum, the ball exerts a force on the tennis ball for a very short time. In cricket, the batsman hit the ball by the bat for a very short time interval, and change of the momentum occurs. Okay, okay, that's all for today. Next, we'll share another topic of your chapter. Till then, be good, be safe, Allah Hafiz.